first question before we get started. This talk goes across 2 time slots, 50 minutes plus 50 minutes. We got 2 options, and I'm pretty flexible for either one of those options. Option 1, we could just go plow through, no break in between. That's option 1. Option 2, go for 50 minutes, 10 minutes break, 50 minutes. Which of those 2 options you want? Everybody is option 2, so with a break, right? All right then, awesome. Excellent. Let's get started. Welcome to the session on Towards an Evolutionary Architecture. My name is Venkat Subramaniam. We're going to talk about what are some of the reasons to evolve architecture, what are some of the ways to actually evolve architecture, what are some of the things we can keep in mind to get a better result out of it. Best time to ask questions or make comments is when you have it, so please don't wait till the end. Anytime is a great time, questions, comments, just about anything you want to talk about. So don't hesitate, just raise your hand, draw my attention, start speaking. Would be delighted to hear what you have to say. So I want to start by talking about one of the things that we often feel as a pain when it comes to developing software, especially in an agile methodology, is how do we really be agile, especially when it comes to developing architecture of systems, and how do we really prevent it from deteriorating so bad that it becomes really a mess to deal with towards the very end or even in the middle of the project. So we tend to really have difficult time creating software in a lot of different ways where the software actually is maintainable over time. So I want to talk a little bit about what are some of the things we can actually do to create better software. But I want to first start by really asking the question, how do we measure quality? Now, quality is something that we always want to keep in mind. We all want to develop something that we can produce results for, but we definitely want to develop something that's of reasonable quality. And how do you say something is of good quality? And we could say, well, if it is readable, if it is, easy to understand, sure, we could talk about all of those. But to me, I would argue a good quality is something that is less expensive to maintain over a long period of time. So in other words, I would like to measure quality by not what we do, but I would like to measure quality based on what it does for us. So I want to be able to create a software that I actually can maintain at a very reasonable cost. And of course, one of the disadvantages of that definition is until the very end, when you see the effect of that, are you able to see whether it's a good quality or not? So we definitely want to create quality software so it becomes maintainable, becomes easier to change, and becomes cost effective as well over time. So we want to definitely create things of quality, but at the same time though, we want to be able to create in an agile manner. So what does that really mean to create software in an agile manner? Well, everybody is agile today. Is there anybody who tells you that they're not agile? Right, everybody is agile. I work with a lot of companies. I walk in, and the very first thing they want to tell me is, oh, we are agile. And I tell them, I'm so glad we got that out of the way. Now let's talk about what you actually do. And it tends to be that they want to say they are agile, but not everybody has a good understanding of what really agile means. Well, to me, agile development really is about developing software based on feedback loops. And to me, feedback is one of the most critical aspects of agile development. And what does feedback really do? Well, we create something, we give it in the hands of the users, and see how they like it, if that solves their real problem. And if it does, that's great, and oftentimes it doesn't. And then they tell us what that really should do. And based on the feedback, we come back and make changes to the software, and then we move forward from there. Now, one of the things is the only thing that's constant, as Heraclitus said, is constant. And constant is the only constant. Everything keeps, change is the only constant, and everything keeps changing all the time. And so we need to be able to afford this change. In fact, one of the core principles of XP was to embrace change. Well, if you're going to be embracing change constantly, how do you really make sure your architecture and design doesn't get out of hand, become really a total mess? And that's really what we want to really think about and focus on. For that reason, I think we should really talk about the first thing, what is architecture? So I'm going to give an opportunity for you, and don't worry about being right, don't worry about being wrong. At least I'm wrong most of the time, or my wife says that. So that doesn't matter really, but think about what is architecture. So what is your definition of architecture? That's the first right answer I get every single time I ask the question. So what you just told me is, architecture is something you feel, but you cannot put into words. Absolutely, I'm with you on that. It feels that way as well. Let's give a second definition. Now let's put it in words. What do you think is architecture? It's a design, okay? Well, then the question is, why have two names? It's a structure, and design has a structure too. And I'm not saying you're wrong. I'm just saying these are the confusions we often have, right? Me included. If you ask me, I'll be giving you the same answers as well. So we said it's a structure, it's a design. What else is it? It's a way to communicate, okay? It's an integration. A configuration, okay. What else? It's something that is hard to change. My mother-in-law's attitude is hard to change. That's not an architecture, right? Well, but you're right. I'm just giving you a hard time. But yeah, absolutely, something hard to change. But should it be? Or in fact, it's even better. Hey, this is a total mess. It's hard to change. Yes, we created a great architecture, right? So it's a very dangerous definition to go through. What else can we think of? Different building blocks. So we could say it's really, so if you want to ask what an architecture is, it is a structure, a high level design of building blocks, of components, and how they are connected. I just pulled everything you said and brought together a definition, right? So every word you mentioned is almost there. And going further, it is often really hard to change. We also said that. And in fact, if you haven't had a chance to read this, I highly recommend a little article. It's only about 3.5 pages. So you'll read this in about 10 minutes or so. And the article is called, Who Needs an Architect? And this article is by Martin Fowler. And I usually often recommend every developer ever come across, read this article. If you Google for it, it's 3.5 pages. Now, I came to know about this particular article through one of my friends, but I was in a conference doing a Birds of Feather session with my good friend Glenn Vanderberg, and we both were, I was standing about 2 feet away from him. And one of the questions the audience asked was, what's architecture and what's the role of an architect? And immediately I responded saying, I really have to say, I hate architects. And the minute I said I hate architects, I realized my good friend Glenn Vanderberg was the chief architect in a company at that time. I immediately took several steps away just to make sure he doesn't throw a punch at me. And Glenn looked at me and said, well, I'm a chief architect, and I do hate architects. And why do we tend to really hate architects? Well, the reason often is, people are very eager to move into this position of architect. Seems to be a very aspiring position to go into. But what happens in reality with a lot of architects? I'm clear, I'm going to say there are exceptions. I'm not trying to draw a statement where every single person in the world is like this, but I'm just referring to what most people end up being. Most people end up being architects. What do? They tell you how to do architecture. And once they tell you how to do architecture, they often, unfortunately, are not involved in day-to-day aspects of the software. And there's a tension between the architecture they want to create and the architecture the team wants to implement. And oftentimes, there's another danger. Some of these architects would tell you when they used to code. And this is a very dangerous situation to be in. Because if we don't know how to develop software with a certain library or a framework or a tool, it's really not so easy to connect to this. I'm especially talking about application architects. And I have a fond name for those architects. I call them the PowerPoint architects. These are very dangerous people. They can do really beautiful PowerPoint, and they don't do any real work, and they create a mess, and they usually leave before anything actually gets done, and the team is left behind working on it. I was in Poland yesterday, and there was a gentleman who was giving a talk, and he showed a huge complex system in front of us, and it had an unbelievable amount of complexity. And then he showed and said, you know who did this? It's the architects who created this. And you know whose problem it is now? It's mine, because I have to maintain it. That's what he said. And this happens really a lot, because when we don't really understand what we are creating, when we don't have the skin in the game to create it, it becomes really dangerous. So we don't want PowerPoint architects. Well, Martin Fowler talks about who needs an architect, and I won't tell you everything about what's in this article because it's a lot of fun to read. I don't want to spoil the thrill for you. But one of the things he talks about in there is he asks the question, what is architecture? And Ralph Johnson, one of the authors of the Design Patterns book, as you know, well, responded to that question, and he said, well, architecture is often something very difficult to change. We perceive it as something very difficult to change, to the point you made earlier. But he goes on to say that architecture really is a way to make sure the entire team has a common vision of what is being created. So it is really a shared knowledge of the application architecture, is a shared knowledge of the entire team. So when it's a shared knowledge, everybody in the team, programmers, design, people involved in UI design or UX design, people involved in testing, business analysts, all of them put together need to have a shared understanding. And we say, yep, that's what we want the system to do. And this architecture is helping us to meet that particular goal. It's a shared knowledge. When it comes to a shared knowledge, there is also a theme in there. It cannot be something that is way too detailed that sharing of the knowledge doesn't become useful anymore. So one question to ask is, how do we create a document an architecture? Well, some of us are really interested in documenting, and we document like crazy, right? And I've done this in the past. I would sit there and document everything I do, and we realize something that happens over time. How many times have you heard people say, well, the code is not really doing what has been designed? You hear this sometimes. Well, I actually disagree with that, because a code never does anything different from the design. The code is always in sync with the design. What we are saying usually in this case is we are saying that the document has gone stale. The document is not in sync with the design and the architecture. There's a very easy way to fix it. Don't document it. If you don't document it, it never goes stale. Well, then you say, well, if you don't document it, how do you really communicate the architecture between teams? Because that communication still has to happen. So my definition is, a good architecture document should be about 5 pages long. If you cannot tell me what your architecture is within 5 pages, that's not an architecture, that's a novel. And that is not going to help anybody understand what's going on. So a good architecture document should be about 5 pages or less, and you can quickly look at it, get a glance, and get somewhat relevant information. Well, what about all the other details we need to know? Well, we need to know more details, certainly, but how do you communicate that detail? Well, I'm a huge fan of movies. And one of my favorite movies, and you probably have seen this movie, is a movie called A Few Good Men. Anybody has seen the movie, Few Good Men? Not a single person? You know what to do tonight then, right? Well, so I'll tell you a scene from the movie that I really like. There's a scene where there's a court scene, and there is Kevin Bacon interviewing one of the privates, and he's asking, here is a manual from the Marine Corps, and tell me where in this manual it defines what this process called code red is. And he says, no, it's not defined in this manual. He says, all right, here's another one, and here's another one. He says it's not defined in any one of them. And then he says, so I've proven to you this is really not true, you're lying, there's no such procedure, and he's walking back. And along the way, Tom Cruise intercepts him, grabs the manual, goes back to the private and says, in this manual, can you tell me where it says the mess is? He says, no, sir, it's not in this manual. What about in this one? No, in this one. Well, private, are you telling me in all the time you served in the Marine, you are actually starved, you never ate meal? He said, no, I had a 3-square meal every single day. Well, how could you have a meal if nowhere it is documented where the mess is? He said, sir, when I was hungry, I just followed the crowd. And I'm a huge fan of this following the crowd kind of documentation, right? So when you come into a team, the members of the team can help you to really get up to speed on the architecture and the details you need to know, where that 5-page document can be just a little starting point, a communication point, and you can get into the details very quickly. So documentation is necessary, but it's got to be very much to the point, and that is one of the things to keep in mind. But what about this thing about hard to change? What can we do about it? Well, that's one of the reasons why we should really make the architecture evolutionary. Now, why should we really make the architecture evolutionary? And the reason really is software changes constantly. If somebody tells you they designed and implemented a software and they never had to change it, what they are telling you is their project got canceled and nobody is using it, right? So any software that is relevant has to change and people have to use it. So we have to constantly change software and adapt it. And so for that reason, we have to evolve it. Now, one of the problems we have gotten into over time is this interesting mess we are in today. Now, if you look back in time, we did what is called the waterfall approach. And we did this for a long time. We do this today, except we call it agile. But most of us still do this, right? But we have done this thing called waterfall approach. Now, what was really wrong with waterfall approach? Now, I would say the main problem with waterfall approach is this. You are taking on stuff and you are doing stuff in a sequential order. And by the time you get to the interesting parts where there are high risk, you have walked too long in one direction to that particular point. I remember working on one project where we went through requirements gathering for a very long time, several months. We went through analysis for several months. We went through design for several months. And all these time, which was about 9-10 months into the project, you know how our schedule was? We were right on schedule every single day. And then, of course, the time came when the design was over and the programming started. And one day I heard my boss tell in the bathroom very angrily, he said, this project was going so well until these damn programmers got together. Because if they did not have to code, we would be still on schedule. But why do things go wrong when programmers start coding? Well, there is something beautiful that happens when you write code. You can compile it. And then there is another thing beautifully happens when you can compile the code. You can run it. And yet another thing that happens when you can run it, you say, oh shit, this is not what we wanted, right? So that doesn't happen when you are doing design. How do you evaluate the quality of design? Hey, look at that picture. How can we improve? Add some color over there. How do you really get a feedback from a design document? We are not smart as human beings to do design analysis and say, this design is sufficient for the problem. One of the reasons is software exhibits what's called the observer effect. Observer effect is the minute you observe something, you want to change it. And when software remake it, people observe it, they want to come back and change it. So change is the only constant. We constantly have to change it. And when you're in a waterfall approach, there is a time when you realize this is a total mess and it's not going to work. But the problem is, the time you know that it's a total mess is way too late in the game. You have wasted all this time. And for whatever time is left between now and finish of the project, when you find out things don't work, you have exactly one option. That option is called panic. Because, oh my gosh, what do we do now? And that's all you can do. But by having the feedback loop from the beginning, you are getting this feedback every single day along the way. So rather than being panicky, you can be very practical about it. And you can say, well, this is not really going in the right direction. What can we change to get better and get back into the direction? That helps us to really do a better job. So as a result, the problem is really lack of feedback loop. That's what is killing us in this case. Now, on the other hand, this also led to one more thing. We did big upfront design in the waterfall approach. That's what we did quite often. We did big upfront design. But here's the good news. We're all in agile projects today. So what does that mean? We can celebrate happily, no more design, right? This is great. This is absolutely incredible. We're all just dancing on the streets. This is awesome. We don't have to do any stupid design and documentation. Well, unfortunately, we can also kind of get a gut feeling this is not going to be fun in the end. So what is really going wrong? If you really think about it, if you look at big upfront design, what is really wrong there? It's not the word design that's wrong. In fact, I would argue it's not even the upfront that is wrong. It is the word big that is really wrong. So you don't want a big upfront design. Maybe what we should do instead is we should do enough upfront design. How about that? So what if we do enough design in the beginning of a sprint to really get a view of where we are heading, not a thorough design, not something we are not willing to change, but enough design to get a feeling for what this is supposed to do. That can help us to set us in a direction, and we can then of course use the feedback loops to get better at it. So I think we should do enough design along the way, and we have to evolve the architecture continuously and not just leave it to the wayside and say, let that emerge. Now, unfortunately, though, there are a few things. Let's think about when do we create architecture for a minute. Now, let's think about this for a second. Let me ask you this question. Anybody here who thinks architecture is important? Okay, I see hands going up. How important is it? A little bit important or really important? Really important, absolutely. I can't agree more with you. I'm in complete agreement. So we can all agree that architecture is really important. Okay, let's leave the thought aside for a minute. If this is the timeline of a project, would you agree, when do you normally create the architecture? In the beginning. Actually, that's not entirely true. I've actually seen this being created even before the beginning. Right? That happens too. I recently had a client come to me and said, hey, we want to create an application. Can you help us with it? And we got some requirements. That's what they used, the word requirements. I said, what are your requirements? And they said, it's got to support concurrency and it's got to run on the cloud. I said, okay, that's kind of nice. Can you tell me more? And they said, yes, it's got to support concurrency and it's got to run on the cloud. That's extremely important for us. I said, okay, that's cool. Can you tell me what this project is about? And they said, we don't know that yet. But it's got to support concurrency. It's got to run on the cloud, right? So we make architectural decisions way in the beginning, even before we figure out what we really want to do. And that happens quite often. So yes, we do this in the beginning of the project. Sometimes, very much to the beginning of even before we even start any useful work on the project. Well, that's great. But can we also agree this is like the maturity, the knowledge we have about the application in the timeline. In the beginning, we don't have a clue. We think we do. But about 40 to 50% into the project, things begin to make sense. Things begin to fall in place. At the very end, hindsight is 20/20. We know everything. Would you say that's reasonable? Right? In the beginning, you don't know much. You get to know more along the way. You discover things. Of course, when you're done with it, you know pretty much what the project is about, right? Well, I used to work for a guy, and he used to use the word, which was really a very interesting way to think about it. He used to use the word called RAD, R-A-D. Anybody remembers what RAD stands for? That's what I thought, Rapid Application Development. He said it's requirements after delivery. Right? Once you deliver the software, you define what this is about, right? You're always right. So the point really is, we don't know a whole lot about the project until we get to the very end of it. And right about the middle is when we begin to make sense. Well, if this is true, and I've seen this to be true on a lot of projects, what we are just saying is, we all agreed architecture is extremely important. Don't screw it up, and yet we're going to do what's most important when we have the least clue of what we are actually doing. What an irony. This is predictably irrational, isn't it? How could we build something so important when we don't have a clue what we are actually building? So that is a very high risk. We are building something that's very critical without knowing what we are actually building. So it's extremely important that we actually evolve the architecture rather than committing to it in the beginning. I'm not suggesting you should not create an architecture, But oftentimes, it's not creation of architecture that's a problem. It's the decisions we commit to in the beginning that often becomes a problem oftentimes, and we are committing to decisions way too early than we should really be. So what we really want to do is to evolve the architecture. And what if we take the first several sprints on a project and say, we're going to start working on the architecture, but we're going to clearly label it as architectural draft. We're not going to call it architecture. We're going to call it architectural draft. We're going to go around and say, I'm the architect in the team. I will not deliver the architecture. I will foster the team to create the architecture, but we are going to only work on a draft for first several sprints until we begin to really understand what we are actually building and how things begin to fall in place. So we should create an architecture draft, but not an architecture in the beginning, and we should start evolving it along the way. But of course, we always have risk in everything we do. I'm going to talk about both the risk. What's the risk of not evolving an architecture? But let's not be naive about this. There is also risk in evolving an architecture as well. And for being objective, we got to see both of those. What's the risk of not doing? What's the risk of doing it as well? Well, there are some risk of not evolving the architecture. The first risk is the architecture that we create is becoming, architecture is irrelevant. So how many times does this happen? So the architecture we create is irrelevant, and as a result, it becomes really painful to maintain this code over time because it's really not relevant to the problem that we have on our hands. And what happens when it becomes really irrelevant? We are trying to really fit everything into this architecture. It becomes really painful to evolve, and we see this quite often. We see this in companies where a change comes through and they need several months to make the change. I worked with a client recently here in Europe, and I was asking them how they would go through a certain change, and they told me for implementing one feature change, they need about 10 weeks, and they have to work with 8 different teams to make it work. I asked them, for this feature, does your competition go through 10 weeks? And they said no, they keep releasing features like this every three weeks. Now, why would you want 10 weeks or 20 weeks to get software, changed? That's a sign of architecture standing in your way. For example, not letting you achieve what you really want to do. It can become really problematic to move forward. But here is another problem. When we create architecture that's irrelevant, what happens in that case? It's usually because there is either an architect or an architectural committee that is sitting there, and I call them the policemen. The policemen sit there with a big stick, and they say, you will do this. And everybody is like, okay, we're coding the architecture. And when this happens, there are 2 things that often come out of this. When a team is forced to implement an architecture, either the team forces themselves to implement that architecture, which is no longer relevant, and it becomes expensive to maintain the software over time. That's one thing that happens. The second thing that often happens alternately is the team quietly ignores the architecture. And the architects, of course, don't code, so they don't know this. They're in this beautiful world in the ivory tower saying, aren't we good? Because the architecture we created is being implemented. And the programmers are looking down, it's like, be quiet, never talk about it. When they come for a discussion, you say, this is awesome. We're implementing this, it's worked awesome, right? And so they're completely deviated from the architecture, and there is no relevance at all anymore. Have you seen that happen ever? Yeah? So we kind of quietly deviate and get things done, and now we are in this disjoint world, and the architecture effort did not help us at all. We kind of let it run rampant. And of course, when problems emerge, that's when we really begin to discover that things really were not really governed properly. So that is those are some of the risks of not evolving the architecture. There is, though, the risk of evolving as well, and I'm going to say there are 2 ways to think of risk. I'm going to talk about a feature that is known, and then I'm going to say a surprise feature. And I want to talk about both of those one at a time. A feature that is known. So we are evolving the architecture, So we have, let's say, about 10 sprints on our hand. And every sprint we are adding feature and adding feature. And now we are in the 7th sprint and we have taken a feature to implement and we suddenly realize, oh my gosh, this architecture will not support this feature. We are in trouble. We got to change a lot of stuff and the sprint cannot finish anymore. We need 4 more sprints to rework the architecture. Well, that's one risk we're going to get into, is a feature that is known on the project. We try to implement it in a sprint and the current architecture doesn't support it. Is there a possibility of that risk? I think there's a very high possibility of that risk and we should definitely handle that. So how do we really handle that particular risk? Well, one of the ways to handle that particular risk is don't take stories and split them across the sprints. This is a terrible idea. So don't take stories, right, and split them across sprint, because what are we doing here? We are simply saying, here is a boatload of stories to implement, divide, this one here, this one next, this one next. Well, that is a blind way of planning the project. We need to do active planning and governance, and the point really is, first is prioritize. So you prioritize the project based on 2 things. The first priority is value of stories, but that's not enough. I also want to prioritize based on the impact on the architecture as well. So I'm going to take stories. So a story S1, story S2, story S3, and so on. And I'm going to first of all say, what's the business value? And I'm going to say, what's the architectural impact? If the business value is, let's say, 10, and the architectural impact is 10. On the other hand, story 2, the business value is, let's say, 8, and the architectural impact is only 5. Now, on the other hand, the story 3 has a business impact, a value of 8, but an architectural impact is, let's say, 9, and so on. Well, what does this tell us? It tells us that here are some stories that we have on our hand, but the stories have very different business values, and the stories have very different architectural impact. Now, before we go any further, there is something this implicitly tells us. In the planning phase, you need to have people who understand the business. But that is not enough. You also need people on the project who also understand the architectural consequences. So a planning has to happen among business people and technical people working together. And we don't do sprint planning properly most of the time. We kind of come to the team and say, hey, we want you to give estimates. Well, that's too late in the game. We need to have a planning where at least a sprint and a half before a sprint starts, when the business people, the customers, as I call them, business analysts, and technical leads from the team, I'm not using the word architect here, but technical leads can sit together and they arrive at the estimation based on the prioritization. So you say, here is the business value, here is the architectural impact. What am I going to do in sprint number 1, sprint number 2? What am I going to do early on in the project? I'm going to move what is high business value and high impact first. And anything that is low business value and low impact comes later. Now, what's the benefit of this? The benefit is you come to the 7th sprint, you take on a story and you say, wait, this doesn't fit into the architecture so well. You know one thing about this is not as important as what you have already done, because what is more business value has been done by this time in terms of how you prioritize it. And as a result, you are okay to compromise on this feature because it is less important compared to the features you've already implemented, and so you can do a better compromise to get around it, rather than saying, this is so important and we have to change everything for this sake. So you can be a lot more flexible about it. The second thing about this, though, is if you do this approach, what's going to happen in the beginning? Your velocity in the beginning is going to take a beating. So you're not going to show a very high velocity in the beginning. And I want to emphasize, I really hate the word velocity, because it's a very wrong way to look at how we develop software. Because if you tell the team you want better velocity, what is your team going to give you? Better velocity. But they're not going to give you a product that is better to maintain, easier to maintain, and provides value. So I would rather have little less velocity in the beginning. Where velocity matters to me is in the end, not in the beginning. If you're really fast in the beginning, I get very nervous, because what that means is when more difficult things come in the later time, you're going to get stuck. I would rather you have a slower velocity in the beginning, doing tougher things first, so the going gets easy towards the end, which is when we want to really get this out of the door with whatever features we have built so far. So I really don't care about higher velocity in the beginning, and so we have to be very careful in how we plan this as well. So given this, we want to really approach this based on the business value and the architectural impact. Well, this can be done for features we know about already, but life is not that kind all the time. We have features that was never expected. Your organization, maybe your marketing folks went to this conference or a trade show, and they were sitting there and they overheard or saw a presentation from a competition, and they are implementing a feature. And they come to the office, or more than likely, like my marketing folks often, they don't come to the office, they are texting you right from the conference saying, we are in trouble. That's usually the message starts, right? We're in trouble. It's like, okay, calm down, sit down now, what's going on? We just saw this feature from the competition, our life is over unless we implement this. Well, these are the surprise features, right? Nobody ever thought of these features, but all of a sudden, we should have it or we are dead. Well, how do you deal with these kinds of features? The first thing I want to emphasize is, what if you did the big upfront design of software? Well, you did the waterfall design, or you created a wonderful, massive architecture. Well, surprises do not come to you and say, are you guys evolutionary? Well, I got a surprise for you. Right? No, it doesn't do that. Surprises don't care what you do. Surprise is going to be there no matter what you do. And as a result, that kind of surprise feature is going to happen in the big upfront development. It is also going to happen in evolutionary as well. So we have to deal with this in both of those situations. This is not unique to evolutionary architecture. However, I'm going to claim that in an evolutionary architecture, you are in a better situation to handle this than in the big upfront design. And the reason is, we're going to take a very minimalistic approach in creating the design and architecture. And when a change has to happen, you don't have a lot of stuff making it really hard for you to make those changes. In a way, think about this. If you really have to run, would you rather run on an empty street or through a crowded mall? A big upfront design is like a crowded mall. You want to make a change and everything stands in front of you and says, I won't let you go, I won't let you go, right? And it becomes really hard. Whereas when you do minimalistic design, it's very sparse. It's easier to make a change when you have to make a change than when you have built a lot of stuff around it. And so we can be better prepared at this as well. Well, that's what we're going to do, is look at some of these principles we can follow to deal with this. So we talked about why we want to do this and some of the ways to really begin to approach it. But I want to get something somewhat a little bit more concrete. What are some of the ways we can actually build an evolutionary architecture? The very first thing we should do is we should keep things simple. Well, that is one of the most easiest things to say, but the most difficult things to actually do. And one of the reasons why it's really hard to keep things simple is most of us, me included, quickly can tell we should keep things simple, but we don't have a clue what simple really means. And it's really hard for us to understand what simple really means. We often get confused about simplicity. When something is familiar to us, we think it is simple. But it's really not that true at all. It is just that it's familiar to us. When something is not familiar to us, we may feel it's complex, but that's not true. It's just that it's not familiar to us. So we need to really take the time to ask, is this really simple? But how do we define simplicity? I would say simple is something that keeps your focus. It doesn't distract you. It doesn't confuse you. So when something is simple, you can look at it you get it, and it doesn't have anything extraneous in it. Simple is something that doesn't solve problems you really don't have. Simple is very targeted to solving your real problems. Simple is something that is easier for people who know the context to understand, but it's important to know the context first. And so we need to really establish the context and then make it simple as well. So, but what happens when things are not simple? When a system becomes complex, we deal with two kinds of complexities in what we do. There is the one complexity we always have to deal with is called the inherent complexity. This is something from the problem domain. There is nothing you can do. You cannot wave a magic wand and say, I'm going to remove this complexity. That's a complexity of your domain. Imagine you are dealing with taxation. I can talk certainly about US taxation. It's a total mess. And the amount of complexity involved in it, nobody can understand and deal with it. And imagine you are developing software to deal with taxation. That is your inherent complexity that you have to deal with. But then most of what we deal with is accidental complexity. Now, a good simple design should, so a simple architecture, simple should remove accidental complexity and hide the inherent complexity. That is one of the ways we can actually deal with complexity in a proper way. So you don't want accidental complexity to be on your face and you have to deal with it every single day. Think about this for a second. You're writing an application and you decided to use a concurrency library. Maybe you decided to use the Java concurrency library, the JDK concurrency library. Well, what are you doing now? You are creating threads, and every corner you turn, you got locks and synchronize, and every corner you turn, you got more code to deal with concurrency. What is that called? That's called accidental complexity. And this happens sometimes when we get overwhelmed by this complexity. A lot of our effort goes into dealing with this complexity rather than delivering value to customers. And that's when we have to step back and say, have we gone in the wrong direction? Should we maybe step back and use a different solution and get rid of this complexity? It's very easy to get dragged into this. I'll give you an example of this. I had a client of mine call me and say, we got an enormous problem with concurrency. We got huge deadlocks, and don't worry, I fixed it. That's what this person said. But we want to make sure, now that I've fixed it, we want to make sure we don't get into this problem again. Could you please come and help us and see what the problem is, and we can, help remove it so we don't get into this mess again. So I went in there, and honestly, before I went in there, I'm a human as much as anybody else is. I'm as flawed and imperfect as anybody else is. So I thought of a lot of wonderful solutions for them without knowing what their problem is, right? And I listed down, I could solve the problem for them, this solution, I could use this kind of architecture, I could use this kind of solution. I had so many beautiful answers for them. And I told them, send me your code, I want to review your code before I come there, so I'm intelligent about what you guys do, and so we can talk about it. So I go there and I was on I was traveling from Europe. So I was reading through their code through this very long flight. I guarantee you, there is no better in-flight entertainment than reading somebody's code. So I'm reading through this code on the flight, and so I land there, and I go to the client side on Monday morning, and I sit down with them and said, tell me what your problem is, let's talk about it. And this architect goes through for a good 2 hours and explains to me what their application is, what their business need is, what their architecture is, and what their problem is. And I quietly listened for 2 hours, and then I said, hey, thanks for explaining all of this. Could you please go over your concurrency needs for me? Oh, of course. And he goes for another hour explaining it for me. At the end of the hour, I said, thank you for explaining that. That's really good. If you don't mind, could you please explain one more time that little concurrency need? What does the user do and why do you need concurrency? He said, oh, sure. And he goes for another 30 minutes and explains it to me. I said, this is great, thank you, but please be patient with me. Can you explain to me one more time why you need concurrency? He takes a deep breath and says, okay, and goes for another 15 minutes. At the end of 15 minutes, I said, I know you're going to get angry at me, but please be patient. Can you explain to me one more time why you need concurrency? He's like, let me see how I can explain this to you, Venkat. And then he stares for a second and says, damn, are you telling me we don't have a need for concurrency in the first place? I said, do you? And he kicks the wall and says, damn, do you know how much money we have wasted on this project? 70% of their code dealt with concurrency when they have no need for concurrency at all in the first place. And when I looked at this and said, well, here is your user request coming in, there is no concurrency need at all. Every user is independent of every other user given a time, and the little time when there is an overlap, there's a database called database transaction, which takes care of concurrency for you. And they said, well, thanks for coming. Looks like we don't need you anymore because we don't have a problem to solve. And I left early. And this is an example of accidental complexity. We are solving problems we really don't have. And when we do solve problems we don't have, who is going to maintain all that code? Who is going to maintain all that architecture? Who is going to maintain all the system for years to come? That's a complexity we carry with us. So a simple design should remove accidental complexities. And it should let us focus and hide inherent complexity in the system. This is not easy. It takes a lot of effort for us to be able to get there. And we have to work really hard, constantly asking, is this simple or is this complex? And if we can identify this as complex, one of the things I would encourage people to say is, you don't have to have answers for every single problem. Sometimes you feel the pressure. If you suggest something, it's like, I got to really show you how to do this. No, let's first agree this is complex. If we cannot even agree this is complex, we cannot find a solution for it. Once we agree it's complex, we can put our hearts and minds into it, and we can find the solution for this complexity, but we have to get a grip on that first, and that is something for us to do to begin with. So the first step is, we got to keep it really simple. So remove complexities, accidental complexities, hide the inherent complexity, and work towards solving only the problems you really, really have, and not the problems you really don't have in your system. It requires enormous effort to get to that point. The second thing I would say is, you have to really be willing to refactor almost continuously. Refactoring is probably the most important thing we can ever do. Now, have you ever worked with somebody who said, I can sit down, I can do things once, and I can get it done correct? If you had one person who can do it, you were in the presence of some divine power. Right? No mortal human being can ever do anything in the first time ever correctly. And we learn constantly and we have to improve. I'm a huge fan of this slogan called make it work, and make it better real soon. And that real soon is very important. Not in the next 7 months or 8 years, but real soon. So we constantly have to refactor what we create, and that is something we have to do. Make it work, make it better real soon. That applies to architecture, that applies to design, that applies to code, and we have to constantly reevaluate and make it better. And if we are not willing to refactor what we create, there is really no hope for us to get towards a better architecture, a better design. So we have to really work continuously towards refactoring. And refactoring should be a very important daily activity. It's something you don't just say, we'll do it when we have time. It's a part of what we do every single day. If you really think about this, it's just amazing to see how we got it so wrong in our field. We come across so many developers and managers and companies which believe we got a one shot at developing this software. This is really stupid if you really think about it. If you look at some of the greatest of minds in the world. If you look at the work created by Picasso or any of the greatest artists of ever who lived, they never created the masterpiece in one sitting. They always created very many prototypes, and then they created the masterpiece eventually. And then we feel we can sit down and write code once and get it right. Now, clearly, some of us feel that this is engineering and there's no art in it. But unfortunately, software development is a healthy combination of both, and we cannot ignore one and focus on the other and be able to succeed with it. So it's important for us to continuously evolve and refactor. That is something we have to be very willing to do. So when we come back from the break, I'll start from refactoring, and I'll go through certain other principles we can talk about as well. So let's take a break, and we'll continue right after that. Thank you.